discuss about special purpose diode part 2. We have seen already special purpose diode part 1. So don't waste time here. Let us start with today's outcomes. Here we can see this is the outcomes for today's lecture. First we will discuss about tunnel diode, and then after pin diode, and last solar cell. In tunnel diode we are going to discuss about its symbol, operation and its characteristics. Number 2, in pin diode we are going to discuss about its construction, working principle along with its applications. And finally we are going to discuss about solar cells, working principle, equivalent circuit and its applications. So these are the outcomes for today's lecture. Now let us start with number 1, special purpose diode is tunnel diode. So here we can see, first we are going to discuss about its construction. It is one junction, two terminal negative resistance type semiconductor device. It is basically semiconductor device, but with changes in impurities, level of impurities, it becomes special purpose diode. It is used in amplifier, oscillator and switch at high frequency. Here we can see this is the symbol of tunnel diode. It is slightly different compared to the PN junction diode. And beside this, here we can see this is the actual appearance of tunnel diode. So it is look like this in practice. Tunnel diode is heavily doped semiconductor with impurities. Tunnel diode electric current is caused by tunneling. So we are going to discuss about this tunneling techniques. The tunnel diode is used as a very fast switching device in computers. So let us discuss about why it is known as tunnel diode and what is tunneling. So here we can see, if we create PN junction diode with the help of fabrication method or chemical process through, at this time the junction is developed between P and N type material. When it is in unbiased condition, there will be a depletion region is formed in P type and N type region. This depletion region is depend on impurities. Impurities is nothing else. We are going to add the doping level is high, width of depletion region is less. So the value of potential difference becomes low. That means if your impurity level is high, number of electrons and holes are high, so it pressurizes on depletion region width. That means your width of depletion region is reduced. That's why depletion region is also known as barrier potential, and it is also reduced. Here we can see that means if depletion region width is lesser, at this time if we apply small forward or reverse bias current at this time, then the charge carriers get sufficient energy and cross this junction and can go from one side to another side. So this process of crossing the carriers from one side to another side at low voltage is known as tunneling, because at this time electron get energy and it create tunnels from that depletion region and goes to one side to the another side. So it is called as tunnel diode. It is look like if you are digging mountain from one side to another side, so it becomes tunnel. So similar here, electron can tunneling from go to one side to the another side. So that's why it is known as tunnel diode. Here we can see this is the VI characteristics of tunnel diode. So reverse and forward characteristics of tunnel diode. For this VI characteristics, as we discussed earlier, that VI characteristics, that means on x-axis we are plotting different types of voltages, and at y-axis we are taking different currents value. So here be specific, it is reverse and forward. So on x-axis we are plotting voltages, at y-axis we are plotting different currents. So if you are giving reverse bias, that means your graph will be look like this here. And then after, if you are giving forward bias, then with the increment of voltage your current is varying. Here we can see, I particularly used here word vary because it is not increase continuously or not decrease continuously. First you can see it will be increased, then after it will be decreased, then after it going increase. So here this is the VI characteristics of tunnel diode. Now here we can see this is the reverse voltage, and here this is the reverse current. So this is reverse characteristics for tunnel diode. Now discuss about forward. Here we can see this is the forward current and here forward voltage. I mentioned here, if we increase forward voltage, then gradually your current will be increased. Here we can see straight line, that maximum value, peak value of these characteristics is known as peak current, and lower current is known as valley current. Here it is indicated as IV and IP. So IB, that means valley current, and IP, that means peak current. Similarly here at x-axis we can see VP, VV. VP, that means peak voltage, and VV, that means valley voltage, and here VF, that means forward voltage. So this is the characteristics of tunnel diode. Now A, B, C, D, E, F, these are the different regions where the graph behaves differently. Now for A region, if you are increase particular voltage, so at the A region you can see current gradually increase. Then it becomes peak IP, which is the point known as B. Then after, if you increase more voltage, after that you can see here clearly that in C region your current is going to be decreased. Well, it should not happen in any characteristics, but it happens here, because that's why it is known as special purpose diode, because this BCD portion of this characteristics is used for oscillation, and this characteristics is known as negative resistance characteristics of this tunnel diode. So this is the special thing about tunnel diode, which is also used in oscillator. So this is the characteristics of tunnel diode, and after this D point it will be going to increase continuously in forward bias. So this is the tunnel diode. Now next, let us discuss about PIN diode. So first, it is made up of 3 semiconductor materials. So it is look like transistor PNP, but it is not transistor because we are using P and P material in transistor, whereas here we are going to use P, I and material. So I, that means it is intrinsic layer or intrinsic material. Intrinsic, that means it is undoped, or we can say it is pure. Whereas P, that means P-type material, and that means N-type material. The high resistive layer of intrinsic region provides the large electric field between the p-type and n-type region. The electric field induces because of movement of holes and electrons in this region. Here we can see this is the symbol of PIN diode, or we can say construction of PIN diode. PIN diode is constructed like this. The PIN diode is unbiased, there is a diffusion of electrons and holes across this junction. So due to this diffusion, it produces depletion region in both the sides. So Pi and IN. There will be a two depletion region formed in PIN diode. Now first we are talking about forward bias. When PIN diode is in forward bias, the width of depletion layers decreases. Obviously, if it is in forward bias, that means number of electrons flowing from N to P side. That means width of depletion region becomes reduced. So more carriers are injected into I region. That means in I region more carrier charges are injected. This reduces the forward resistance of the diode and behaves like variable resistor. That means it varies. The forward resistance of intrinsic region decreases with increasing current. So that's why here we can see the symbol, or we can say equivalent circuit of PIN diode for forward region. For forward bias, it is variable resistor, because whenever you increase the current's value, then your resistance becomes decrease. Now next, for reverse bias. When PIN diode is in reverse bias condition, the width of depletion region becomes large. At a certain reverse bias voltage, the entire intrinsic layer will be swept out of charge carriers. This voltage is called as swept out voltage, or we can say swept in voltage. At this stage, PIN diode works as a constant capacitance. Now, in reverse bias condition, your PIN diode is equivalent to the constant capacitance. Why? So first of all, we have to knowledge about capacitor. Capacitor is two conducting plate material. Between these two conducting plate, there is an insulating layer or one region, which is called as dielectric medium. Similarly here in PIN diode, this type of construction is formed. That's why it behaves like constant capacitor, and its symbol is CR, that means reverse capacitance, because it happens in reverse bias, that's why. So PIN diode's applications are, it is used in detector circuit. So that's it for PIN diode. Now next, this is the solar cell, which is also called as photovoltaic cell. Solar cell, it is also known as PV cell. It is defined as the electrical device that converts light energy into electrical energy through the photovoltaic effect. A solar cell is basically PN junction diode. This is nothing else. This is only PN junction diode, but few changes are made to make it different. Here we can see this is the construction and symbol of solar cell. So first of all, construction. Above, this is the reflective glass, transparent glass layer. Then below it, P region, and after that N region is formed. Why here we have to connect glass or reflective glass? Because direct sunlight photons are reflected on this glass, and due to these photons, minority carrier charges in p-type regions, which are electrons, get energy from these photons and becomes free and move to the n region and make a pair with holes, and that's why current flows from this circuit diagram. So let us discuss about in detail in working of solar cell. Till then, see this symbol of solar cell, plus polarity and here minus polarity. So remember this one, we are going to use here in working principle. It is essential to consist of silicon p-n junction diode with a glass on top surface of p-type material is made extremely thin, because if it is thin, then photons can easily strike on p-type material. And remember this, there should be a p-type material is above and near to the glass, and n-type material is below, that means far away from that glass. Here, in this way, free electrons and holes are generated on both the sides, and that's why this electron-hole pairs generated current, or we can say produce a current through this process, current flow from this circuit. So here we can see this is the symbol of solar cell. This is look like photodiode, but there is a big difference between photodiode and solar cell. So its applications are in automatic exposure camera lighting, or we can use in burglar alarm, or many more. Mini project can be built by use of this solar cell. Photodiode is basically similar to the solar cell, and it is also similar to the LED. Here we can see this is the symbol of photodiode. It's slightly different compared to the LED. In LED, we have seen that this arrow's indication is outside. But here in photodiode, its arrow's indication is inside. That means it absorbs light, whereas in LED, it emits light. So this is the difference between LED and photodiode. Now, solar cell. Solar cell is quite similar to the photodiode, because in solar cell we have discussed about it that solar cell accepts photon or light energy, and through these photons in circuit diagram we can see the flow of current. Similarly here in photodiode it will be happening, but in different manner. Now let's start with photodiode. Photodiode is constructed with the help of silicon and germanium material. It is packed in a plastic capsule. Here we can see this is the actual appearance of photodiode. It is in plastic capsule, and its upper side is totally transparent because your light is emitted through this upper side. So one end of lens is formed such that light is focused on the junction. So it works in reverse biased. If it increases, minority carrier charges also increases. On the top of metal case, there is transparent window where light is striking. We can say which allows light to enter up to the p-n junction. So let us discuss about its working principle, how it works. So here we can see when diode is working in reverse bias condition, then reverse saturation current flowing through it from positive to negative terminal of the diode. Now I am going to discuss about reverse biased condition. That means its width, its depletion width is larger, it's wider compared to the forward one. That means depletion region is spread in p-type junction and n-type junction. So here, if at this particular time when light is struck this depression region, at this time, electron hole pair is generated. When this electron hole pair is generated, it moving towards positive to negative terminal respectively, according to its bias. That's why current is flow at this time. So like this, photodiode is working. Here we can see photodiode, we do same control the conductivity of the device. As the name suggests, in the photodiode, the PN junction gets exposed in the light. Depending on the intensity of light, its electron hole pair is increased. When its electron hole pair is increased, that means photocurrent is increased. That means intensity of light is directly proportional to the photocurrent. If intensity of light is higher, that means your photocurrent is higher. So at this manner, we can say photocurrent is flow from this circuit diagram. Now, according to this, one question may be arise in your mind that why it is working in reverse bias, why not in forward bias? It is working in reverse bias, that's why if there will be slight change in current, so it is noticeable, because in reverse bias the current flowing in microampere. If we strike a light on that PN junction, so it is minor changes and we can notice it, that current. If it is working in forward bias, then forward current flows always in milliamps, or we can say milliampere. And due to this, we cannot measure or notice that current in absence of light. Due to this reason, it is working always in reverse bias condition. Other than, what is dark current? Dark current, that means when there is an absence of light, there may be a flow of current, which is also known as reverse saturation current. It is due to the minority carrier charges. And if your temperature is increased across this junction, that means your minority carrier charges also increased. So that is known as dark current. When there is absence of light, your current may be arise. So this is the all about photodiode. Now let us discuss about its application. Photodiode is most important in optical fiber receiver. Well, we know the optical fiber where light is emitted from transmitter to receiver end. At the receiver side, we have to connect photodiode that senses this light and decode this signal. Also, it is used in cameras where it senses lights. So these are the application of photodiode. So that's all for today's lecture. Till then, keep learning, keep reading. See you soon in next coming lecture. Thank you.